Let's work through the algebraic solution for that potato market tax problem. So we note that demand is just given as P equals 30 minus 0.06 the QD, and supply is represented by the equation 2 plus 0.01 times the quantity supplied. And the equilibrium condition here is that the quantity demanded at our equilibrium price has to equal quantity supplied. All right? So what do we do without that? Well, we just realize that, at equilibrium, this quantity demanded is the same as this quantity supplied, and thus we can just sub-market quantity, equilibrium quantity, we'll just call it Q in for those two, and we get the following. 30 minus 0.06, those are zeros, are not times Q, has to equal 2 plus 0.01 Q. And rearranging, that means 0.07 Q is equal to 28. Divide through by 0.07. And I find that Q is equal to 400. And I can plug this Q into either the supply or the demand curve. So it doesn't matter which. It looks like it's a little bit easier to plug it into the supply curve, and you find that price is equal to 2 plus 100th times 400. 2 plus 4 is 6. P equals 6. So there you have it, and that corresponds to our graphical solution. The tax case is the tax case algebraically is maybe a little bit harder, but let's dive into that. In the case of the tax, we have P. Well, the key thing to analyzing a tax is to realize that we've been using price to mean both the price per sack of potatoes that the buyer pays and the price that the seller receives. But what a tax does, whether you collect it from buyers or sellers, a tax creates a difference between what the buyer pays and what the seller receives. So I don't have to shift supply curves in the case of a tax on suppliers, or shift demand curves if it's a tax on buyers. Instead, I just realize if there's a tax, if I let P be what consumers pay per unit, and let T be what the tax is per unit, sellers pay P for whatever the good in question is, in this case sacks of potatoes, but buyers receive only P minus T, where T is the size of the tax. In this case, it's $3.50 per sack of potatoes. So knowing that, let's go forward. Demand is still P equals 30 minus 0.06 QD. But supply is different because sellers don't receive P. They get P minus $3.50. And that's going to equal 2 plus 0.01 QS. Our equilibrium condition is still quantity demanded equals quantity supplied, but notice that the quantity supplied now can be expressed, if P minus 350 isn't what I want, the quantity supplied now becomes P equals 550 plus 0.01 QS. And all I've done is added 350 to both sides to get 2 plus 350 is 550. All right, so now I'm ready to go. I've got my adjusted supply curve, supply relationship. I'm not drawing anything. Got my demand curve, and now I've got my same equilibrium condition, and the price that buyers pay, P is going to equal P. Sellers get P minus 350, but since P, this P and this P have to be the same, we can go forward 30 minus 0.06 has to equal 550 plus 0.01 Q. And again, I get, sorry, this is Q. Again, I get 0.07 Q is equal. Now, 30 minus 550 is 2450. I divide through by 0.07 to get Q is equal to 350. And that those Qs are in million 100-pound sacks of potatoes, right? Okay, and price, I can get price by the same method as I did before. P is equal to 550 times 100th times Q, and 100 times 350 is 3.5. So P is equal to 9, and then sellers receive P minus $3.50 that has to go to the government, and sellers thus get $5.50. So this is what buyers pay, this is what sellers receive. The difference is the tax. This is the quantity sold. One more little piece of economics for you, a little bonus here, a little extra bonus, a bonus. We often talk in economics about the incidence of a tax. Come on, I got to add. We often talk in economics about the incidence of a tax, the economic incidence and the legal incidence. The legal incidence is just from whom do you collect the tax. If it's a sales tax, you're collecting it from buyers. If you're collecting it from sellers, that's called an excise tax. It turns out that the economic effect of either a sales tax or an excise tax, the economic effect of a sales tax and an excise tax is exactly the same. But the incidence is pretty simple. If you want to know what share of the tax buyers pay, you look at the price that buyers pay with the tax, subtract from that the price that buyers paid initially, and then divide it by the size of the tax. Well, here, the price went up from 6 to 9, so 9 minus 6 is the jump in price of a sack of potatoes that buyers had to pay, and the tax was $3.50. And so 3 over 350 is equal to, let me use my calculator, 0.857, which we usually express this as a percent, that's 85.7%. And the sellers pay everything else, so 100 minus 85.7% is 14.3. And the economic incidence, in this case, the buyers pay so much of the tax and the sellers so little because the price elasticity of demand is really, really low relative to the price elasticity of supply in this case. That's not always the case, but in this case, that's what happens. And so whichever party has the lower price elasticity of demand, that party has the more difficult time switching to other markets to avoid the tax. So I guess the people like potatoes, like their French fries, they're not going to all of a sudden eat rice with their their burgers. Whereas a farmer, if potato crops are getting a lot of money, they can plant potatoes. If wheat crops are getting a lot of money, or the next season I can plant wheat instead of potatoes. And these are just made up functions, but if our real world estimates were this way, that would be why we'd expect to see a higher price elasticity of supply than price elasticity of demand. All right, well, there you go. Bonus, bonus.